Welcome students. In this module, we will discuss about the rational numbers and irrational numbers. So in the previous videos and classes, you have studied what are rational numbers. So I just want to again remind you about those things. Rational numbers, we know they are in the form of p by q, where both p and q are integers and q is not equal to 0. So this thing you have to keep into the mind while differentiating between irrational numbers and rational numbers. Okay, now in the case of irrational numbers, we are having all the numbers which are under root of non perfect square. Now what does it mean? It means that square root of any non-perfect square, like which are perfect square numbers? Perfect square numbers are those which are square of some numbers. Like I can write 1, 4, 9, 16 and so on. These all are perfect square number. Why? Because 1 is square of 1, 4 is square of 2, 9 is square of 3 and 16 is square of 4. So if any of the square number comes under the square root, it will come out the square root and it will become the number whose square it is. I want to say that suppose if there is under root 16, under root 16 can also be written as 4. Why is it so? Because we can write it inside 4 into 4. Out of these two 4, one 4 will come out and it will become 4. Hence, this is not a irrational numbers. So, what I said, all the numbers which are non-perfect square under the roots are known as irrational numbers. Now, I am giving you some of the examples for it. Suppose a number like root 2, the number root 3, root 5, root 7. All these numbers are known to be irrational numbers. Along with that, a very known number which is pi, which you have studied, is also a irrational number. Now you will say, how can be pi a irrational number? Because we can write it as 22 by 7. Pi is an irrational number because this 22 by 7 is not the exact value of pi. We have taken the approximate value which is nearby the value of pi. The value of the pi is 3.14 and it's keep on going. It is neither terminating nor repeating, which is one of the property of irrational numbers. So, all the numbers which are non-perfect square under the root are known as irrational numbers. I hope this thing is clear to you. Now, real numbers are combination of rational numbers as well as irrational numbers. And we know that on a number line, we can plot all the rational numbers. Same way, like rational numbers, we can plot the irrational numbers as well. So, every point on the number line corresponds to a real number, or every real number corresponds to a point on the number line. How to now? This is the question. Rational numbers to be plotted on the number line we have already done in the previous classes. But how to plot an irrational number on the number line? This time I am going to tell you about this. The question is how the irrational number arises. Suppose if I am having a irrational number 2, then how it will come? So let us see. On the number line, if I take this unit, this is 1 unit, okay. If I again draw a line segment which is of 1 unit, so this is 1 unit, this is 1 unit, and if I join it to the origin, then this is 90-degree angle. If I mark it as AOB, suppose this is a triangle AOB. So in triangle AOB, so can you tell about AOB? Yes, our Pythagoras theorem will be applied here, and we have h square is equal to p square plus b square. From the diagram we know that the value of p is 1 square, value of b is 1 square. If you add them, it will become 2. So the value of h square is h is equal to h square is equal to 2. So h is equal to root 2. That says if in a right angle triangle you are having perpendicular and base as 1, then the hypotenuse will come out to be root 2. This says that this distance is of root 2 units. So what we have to do, take the compass, put the needle here, open it up to A, and then you have to put an arc on the number line this way. So wherever it cuts the number line, that gives you the point where the root 2 is there on number line. So here you can denote your root 2. I can name it as C. That means C is the point for root 2. Suppose if you have to draw it for root 3 also. Root 2 we have done. If we have to make it for root 3. In the same diagram we can go for it. Suppose this is root 2 given to you already. This is the base. And if I take one perpendicular which is of 1 unit and then join it here with the origin. Now what will happen? This is the 90-degree angle, right angle triangle. The base is root 2 and the perpendicular is 1. If again I put the values in the formula, what I will get it? Now this time we are changing the name of the triangle. It is AOD. Now in AOD, if I put the values, this time my perpendicular is 1 square and my base is this one, root 2 whole square. So this is 1 plus square of root 2 will give you 2. So this will come out to be 3. So h square is equal to 3 and h is root 3. That means in this triangle the hypotenuse is of length root 3. So simply you have to measure this length and then again put an arc the same way you have put it for root 2. It will come somewhere here and this will give you the point root 3 on the number line. If you have to draw the point root 5, so there can be two ways. Either you can go by this method, root 3, then 2 you know already there. After 2, root 2, root 3, root 4 if you draw, root 4 is nothing but 2. 2 we are already having on the number line. So what you can do, you can directly make you root 5, or you can have a spiral method also. If you go for spiral method, what you have to do? You have to take this as your distance, a perpendicular, and then draw the root 5 here. Or one more method is there, in which what we will do, we will take this as the base of a triangle. So this is of unit 2. This as perpendicular, which is 1, and then join it with the origin. Now it is O, if I take it as A, and this is B. If you look for the formula of the triangle, this is 2, perpendicular you can take 2 square, base you can take 1 square. Then it will give you square of 2 plus square of base. Square of 2 is 4 plus 1, which is 5. So h square is equal to 5 and h is equal to root 5. That means if this is the base, this is perpendicular, the hypotenuse is root 5. Now what you can do, you can measure this distance and you can just plot the point root 5 on the number line. So this is the way how we used to plot the irrational numbers on the number line. You have to do all the questions which are given in the exercise. Along with that, I am giving you some sample questions. You have to plot root 11, root 19 on the number line, and in the next class I will discuss about this thing. So this is all about how to plot the irrational numbers on the number line. If you have any doubt, you can message me or WhatsApp me. Rest of the section we will cover in our next class. Thank you.